All right, hello everyone. We're going to continue from our discussion from half-lives and now move on to nuclear decay. So half-lives are a type of nuclear decay that don't really change the composition of the atom, but there are other types of decay that actually do. So the ones we're going to talk about is alpha decay, then there's beta decay, which is split into two parts. There's a normal beta decay and also a positron emission, which is very similar. Finally, there's a gamma decay. All right, so let's start off with alpha decay. This changes the composition atom. This is when a parent element or atom ejects an alpha particle, which is also just a helium atom, and then it forms a new daughter element or atom. This is also a type of fission reaction where we said a particle's element transforms into two other elements. So our parent starts with this. A is the atomic mass, Z is the atomic number. Then when we go to the daughter element, we subtract the atomic mass by 4, we subtract the atomic number by 2. So that means it makes a new element, and then we have helium. This will make more sense once I go over the example. All right, so for this, we're going to need a periodic table. When I let you work on a practice thing and then also the test, I'll give you a periodic table to work on. The main thing for the periodic table is just the atomic number. I'll give you the atomic mass within the elements themselves, so you don't have to worry about that. We're going to do the alpha decay of uranium-235 and the alpha decay of platinum-175. Okay, so for that, let's go to my paper or Microsoft OneNote. So first, we should remember what the alpha decay is. X, A, Z goes to Y, A minus 4, Z minus 2, plus helium 42. All right, so let's start with the uranium-235. So we're going to start with U-235. And this is where we use the periodic table. We look for uranium. I'm going to try to look for it as best as I can. Right here, 92, that's the atomic number. So 92 goes in the bottom. So remember here, we do the atomic mass subtracted by 4. So 235 minus 4 is 231. And then we take the atomic number subtracted by 2. So instead of 92, it'll become 90. So this changes the atomic numbers. That means it becomes a new element. Let's look at what element 90 is. So 92 is uranium. So now go back to, it'll be thallium. So 90 is thallium. So it becomes thallium-231, thallium-231. And then we take the plus the helium atom. We put a 4 and a 2. So this is all it takes. You take your element I gave you, 235, blah, 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 and just subtract 4 on the top part, subtract 2 on the bottom one, look for the new element for that atomic number, and then we just replace that there. And we're always going to have this helium atom. So the other example I had was platinum. And let me look again what it was, 175. So we're going to do the same thing. We're going to do PT, 175. We're going to look for that. So that's going to be 78. 78. Then we're going to do the same thing as last time. Subtract by 4 on the top and 2 by the bottom. So it'll be 171, 76. And the new element will be We look at what 76 is, OS, and I can't remember that top of my head. I want to say something like osmium, but basically OS. And add the helium atom. I'll give you more practice with this with solutions as well. So that's all there is to alpha decay. Now let's go over beta decay. There's two types, electron emission and positron emission. All right, the first one is electron emission for beta decay. This is when an electron is emitted from a parent atom. One of the neutron is converted to a proton, so it increases the atomic number by 1. And this too also changes the parent atom to a new daughter element. But the atomic mass stays the same. So you can see here, XAZ. When you go to the daughter atom, it becomes A becomes a Z, but if we do Z plus 1 for the new daughter atom, and we had a beta electron. So this is just the electron. For positron emission, it's similar, but this time a positive sign positron is emitted, and one proton from the nucleus converts to a neutron, which reduces the atomic number by 1. So it's the same thing as the other one, except now instead of Z plus 1, it's Z minus 1. Same atomic mass, but Z minus 1. And then we have a positron. So let's do an example here. We do a beta decay of carbon-14 and a positron emission of magnesium-23. So let's do first C14 beta. So I'm going to write the beta equation again. XAZ becomes YA Z plus 1 plus, I'm just going to put the electron. Okay. So we're going to do carbon 14, and this is a 6. If you want to make sure, just go to the periodic table. We have carbon as 6. Then we do Z plus 1. So it can be, let me do a different color. Same thing, let's do as red. So 7, it's still 14, we don't change the number. And then now that its atomic number is 7, it becomes a nitrogen atom. So we have an N plus the electron. So that's it. You just take the same atomic mass, but just add the atomic number by 1 and just find a new one. Now we're doing the magnesium-23 positron emission. And this time this equation is XAZ goes to YAZ minus 1. And then plus the positron. So just making sure, magnesium-23. So atomic number of magnesium, we look here, is 12. So we start off like how we do the other one. Mg2312. And let's do blue this one. We do Z minus 1. So first it's still 23. And this time it's 12 minus 1, which is 11. And that new atom, we look at periodic table, is going to be sodium. So for positron emission of magnesium-23, the magnesium-23 becomes sodium-23. That's all it takes for these two beta emissions. It's very similar. You just basically leave the top number the same, but just change the new element. The last one's is actually very simple because you don't actually have to change anything. The last one is a gamma decay. And this is when a nucleus atoms emits gamma rays. And this causes the mass and atomic number to stay the same. So the neutrons and electrons stay the same, but they have so much energy that they just emit a gamma ray. So you can see here, we have the same A, same Z, but this time we have this new gamma particle, we call it. This symbol is just called gamma. It doesn't have any mass, it doesn't have any atomic number, it's just a light form. Gamma rays are ray of lights that have the highest form of energy. Gamma rays are actually the most dangerous, one of the most dangerous ways of light, because they can actually pierce through your skin and damage your cells. So getting any form of gamma ray contact will really damage your health. So an example for iodine 125, it just stays the same. So for iodine 125, let's find what iodine's atomic number is, 53. Like I said, it stays the same, I-125, 53, and we just add that gamma particle. So it just emits the gamma rays. All right, that's it for this lesson. I'm going to give you a practice. It won't be a practice assignment, but practice for half-lives and alpha and decays. So you can, which will also have a solution. So you can practice that before you can work on the test. The test will cover what we covered here with nuclear decay, but also have parts of nuclear reactions. So be sure to also study that before you work on it. All right, that's all for this. Thank you, and until next time.